Well, good morning, YouTube. I've been asked by fellow YouTuber BW Darrin to do a quick video, I hope, on how to use one of these little devils. Multimeter. Oops, can't get it up. I hate when that happens. Anyway, these are commonly found at Harbor Freight, places like that. They measure voltage, resistance, amperage, all kinds of stuff. And they're simple items, but if you don't know how to use one, I guess they're not so simple after all. But first, let me, before I get started, I think I have a little mess here to deal with. So, through the magic of video editing, let us clean the desk off. Well, it's not totally cleaned up, but it's a lot better than it was. So, first, before we start here, let's just take a look at the meter itself. It's this is a pretty simple meter. Like I said, it's type that you can get at Harbor Freight. In fact, they usually give them away specials sometimes. But it measures AC voltage, which is what comes out of the plug there. That's called alternating current. It has two ranges, 750 and 200. So if you were going to measure the line voltage, which is in the United States at least 110 to 120, you would put it on the 200 scale, and that would be the reading. We're going to do that in just a second, so we'll show you. Next on the meter face, or the selector, we have DC amperage, and that's if you want to measure the specific current flowing through any electronic or electrical device. If you're curious on, or if you want to know if circuit's drawing too much current, you can hook your meter leads up in a way that you can measure that and see what it's measuring. We're not going to concentrate too much on that right now, because that's not really what we use it for. This particular meter can measure anything from 200 microamps to 10 amperes. So, and I'll cover that in just a second. The HFE function is for testing transistors. I don't know of a lot of people in automotive areas that need that, but like I say, that function is available if you desire. It's not something that it's used usually, like I say, working on cars. Now we're getting down to the resistance or ohm scale. Down here we're at 200 all the way up to 2000 K, which is I think 2 meg. That's for measuring resistance in a circuit. More specifically, resistance of a resistor. I'll show you the little thing with the stripes there. That's a resistor. So, okay, that's what that's for. And the most common thing you're going to run into on automotive applications is DC voltage, which is the scale up here. The ranges this meter covers is from 200 millivolts all the way up to 1,000 volts. So that's pretty wide range. And if you're asking yourself, what's the difference? Why can't I just put my meter probes on there and just measure whatever it is? Well, there are auto ranging meters out there. This doesn't happen to be one that you can do that with, but for a simple multimeter like this, you have to know. The best policy is, if you don't know, set it on the highest value. In other words, if you don't know what voltage you're measuring, set it on 1,000. If it reads that, then set it down to 200 and see what it is. It's a simple matter of you know, just testing to see what you get. But like I said, most applications in cars are going to be on the 20 volt scale, because unless you're working on something with 24 volt system, 20 volt scale is what you're going to want. So that's where you would set your meter to. That will read obviously 12 volts, and that should help you get started. Now, as far as we have 3 inputs here on this meter. Alright, they're, to wily electricians or electronics technicians like myself, those are fairly obvious, but they can be a little intimidating to somebody who's not familiar with it. The top one there says 10 amps DC, and that would be used to measure current in a circuit that's going to go up to 10 amps. Now, like I said, we'll probably never ever use this meter for that. So the two we're looking at mainly is the middle one there, which says volts, ohms, milliamps. That's the one your red lead will connect to. Okay, it goes right in there like that. Pretty simple. And the COM, the common lead, sometimes referred to as the ground, sometimes common, goes right there. Okay, pretty simple. Like I said, that's basically the meter and how to hook up the probes to it. Okay. Now, how do you measure things? Well, that's another story. Alright, now, as you can see, I have a couple of clip leads hooked up to a light bulb. And what we're doing this time is we're going to measure to see if that light bulb is good or not, in case you need to do that. You obviously hook up one lead to the little, I don't know what should we call that, but the positive, or the base of the light bulb there. Obviously the base of the bulb itself is a conductor, and as well as the little knob that sticks out the bottom of that light bulb is a conductor. So if we want to see if that bulb is good, we hook it up to our multimeter. Just simple plus and minus, red and black. It's not rocket science. And what we want to do is read the resistance. So we're going to turn this to our resistance scale down here, and down to the 200 ohm scale. Okay, that's 200. Now we can look at the reading, 6.7. Now, what's that mean? Okay, it means that there's 6.7 ohms of resistance in that light bulb. But the bigger meaning is that light bulb is good. In other words, what we're reading is actually the filament of the light bulb. Okay? So as long as there's a reading there, then it's good. Mostly good. I mean, if it was really high, we might, wonder about it a little bit. But so if for some reason that filament was open, it would read like that, which means infinite ohms. In other words, there's no what's the word I'm looking for? There's no continuity. I could not think of that word. Okay, there's no continuity in the circuit, so that means that there's an open. It's just like here when I undid the clip lead. That makes it open. If I clip the clip lead, back to the positive, then we get the reading again. And I don't have a very good connection. Yeah, now, and we're back to 6.8. Okay. So that's basically how you would do that. So that's an easy way. You can do the same thing with a fuse. Anything that you're trying to test on a car that should have continuity to it. I mean, it should register something on the meter. And you want to use, like I said, the resistance scale, the lowest usually value on the resistance scale. So, alright, that's that. Now, how do we read voltage? Okay, now, if we're going to read voltage, we have to know if it's DC or AC. That's AC. Those are DC. Okay? The difference is alternating current that flows through your house. It can be positive or negative when it comes out of the tap there. When you stick your probe in there, you get both positive and negative. It's alternating current. And the meter has to read that, and you put it on AC, alternating current. For reading the AC coming out of the plug, you would be on the 200 volt scale, because here in the United States we have 110, 120 coming out of the plugs, depending on your local utility. Let me set that up real quick, and we'll see that real quick before we go to the DC part. Alright, you see I got my meter leads sticking into the socket, one on each side. It doesn't matter how you hook them up, it's alternating current, it'll read the same. Meter is on the 200 volt scale on the AC voltage, and my particular meter, my utility here, provides me with 116.65 volts, whatever, coming out of the plugs. So that's how you read that. It's it. And like I said, when you're reading alternating current, you don't really need to pay any attention to how you hook up the probes. It's alternating current, it doesn't matter. We can hook that up the other way and it'll read just exactly the same. So that's alternating current. Now again, what you're going to be concerned with in the car is DC, or direct current. And you know, it's just like a battery. Just like these batteries are no different than the battery in your car. You know, you have a positive and a negative terminal, and in order to read that, you have to hook up your meter with the black or common to the negative, and your red to the positive. I mean, it's simple. I mean, if you ever jumped a battery in a car, you know, red goes to red, black goes to black. So, alright, let me hook that up real quick. Okay, for this test, I have my red probe hooked up to the red clip lead, which connects to the positive terminal on the battery, and the meter is set for 20 volts. These are basically 1.25 volts per cell, I think is what they are. So what we want to do is touch the probe to the black probe to the negative end of the battery. If I can see what I'm doing here, and you can see I am pressed there, and if we look at there, we're reading 1.3 volts. I don't know why my camera went off, but it did. But anyway, we're reading 1.3 volts. If I can get there we go. So again, it's simple with the DC. You want your black lead to go to the negative on the battery, your red lead to go to the positive. That will give you the correct indication of voltage. So, you know, that's pretty much that. I don't know what else to cover as far as because there's not really a lot more to say about this. I know Darrin asked me to do this, and I'm not the world's greatest teacher. People used to laugh about, because I knew a lot about computers, they wanted me to teach them. I said, you know, you don't want me to teach you. It's just not something I do. I can work on things. I'm a jack of all trades, by the way, a master of none. In case anybody's interested, because you see my videos, I work on cars, I work on computers, I work on electronics. I did take 2 years of electronics tech and let's see, back in the 80s, early 80s. I went to school under the CETA program, and I had an electronics shop, Swiss TV and Stereo, in VV, Indiana. I operated that for about 3 years, till the bottom kind of dropped out of the TV market as far as TV repair. At that time, it was the Koreans that were flooding the market with cheap electronics. Now it's the Chinese. But you know, when you have a shop and somebody brings in a television set to you to be repaired, and you know, you can go down to Walmart and buy the same thing for far less than the repair is going to cost. I mean, you can't stay in business that long very often. And so anyway, I closed out of that, and I haven't really been into electronics much since then. But I'm kind of getting back into it because I'm retired now, and I enjoy playing with this. And you know, there's a difference between playing with something and doing it for a living. I know you car guys out there know that. If it's your own stuff, you can take your time on it and do what you want. If it's somebody you're working on for a customer or something like that, you have to get it done. It has to be done, basically. And you know, it's not fun anymore then. I guess is the best way to look at it. But what I do here is basically fun for me. So Darren, I hope this helped a little bit. Not the best tutorial in the world, I understand. Let me cover one more thing here. Now, this is a simple meter. Like I said, this is the kind most guys work on cars and things like that would have. Something very simple that, you know, just does simple measurements. Now, if you get into more electronics, you probably get a digital multimeter like this. It's basically the same, but it's got far more settings on it, as you can see. It's just I got this. I forget where I got it. It wasn't that expensive, really. I think $20-something, maybe 30. I don't know. But it does cover a lot of ranges. It measures temperature, it measures frequency, voltage, obviously, current. It's, you know, probably more overkill even for me, but I don't know. It's just something I wanted to get. And I do have another meter, like another digital multimeter. It's a heat kit that I built back in the 80s and 90s. And it has been my main meter for a long time, but I don't know. So, anyway, and I also got that meter there. That is what is called an analog meter, because it has a dial pace with a needle pointer, and it moves up and down according to the voltage or resistance or whatever you're reading. So, digital, and the other one's analog. Okay, that's the difference in that. So anyway, Darren, I hope this helps a little bit. This was not the best thought out thing. I mean, I come in here after you requested it and did this real quick, but it's just, you know, that's about all I know to tell you. I'm on working on cars anyway. If you want to get into more electronics, I mean, you know, there's obviously more to it, but like I say, for the guy that's working on a car, that's pretty much all you really need to know. So, hope that helps there. Thanks for watching.